Hello, Algebra 2. Today we're going to start Chapter 6. Chapter 6 is titled Polynomials and Polynomial Functions. So today we're starting with 6.1, which this is the precursor of getting into the polynomials. We are using properties of exponents. So this is going to be a chapter or a section to review your properties of exponents. So first of all, just reading a number with a power. So a sub n, where n is positive, represents the product of a factor n number of times. So what does that mean? So like 3 to the 6th power represents 3 times 3 times 3 times 3 times 3 times 3. And so you use this type of notation just when n is positive, your exponent, but we can have a negative exponent. We'll talk about that. So the product, when you use n as a factor, so keep in mind when you multiply, these are called your factors. So 3 is a factor 6 times. Okay, and that would be the difference from going from, this could be written in exponent form to just written as multiplication. So here's your list of properties. And this is going to be very important. I would definitely write these down. So take time, pause the video, get these written down. I'll just briefly mention them. The first one is the product property. So when you're multiplying with the same base, you add your exponents. The second one is power of a power. So when you have a power raised to a power, you multiply them. The next one is when you have its power of a product. When you have a product raised to a power, that power goes to both things in the product. The next one addresses that we never leave anything with a negative exponent. Okay, that's just a math etiquette no, we don't leave negative exponents. So if you have a negative exponent on top, you just move that expression to the bottom and it becomes a positive exponent. Or if you have a negative exponent on the bottom, you move it up to the top. And I will go over a little more in class why it's not just magically moved, but kind of looks like that. The next one, anything to the 0 power is 1, and that includes any huge product, all raised to the 0 power would be 1. Next up, if we are dividing with the same base, so that's always important. When you're dividing with the same base, then you subtract your exponents. And finally, if you have a quotient raised to a power, that power goes to everything in the quotient. These are going to be very, very important most of the rest of Algebra 2. And you started these way back in Algebra 1 or before. And for the most part, we start here on the left, and we apply our property and we go to the right. And that's what we're going to do in Chapter 6, but I'll tell you as we get on in the book, we are going to go the other way. We're going to have situations that are starting on the right, and you're going to have to be able to come back to the left. So you really need to know these inside out. And so definitely write them down before you move on here. I'll catch you on the next slide. So we can use properties of exponents to either evaluate numerical expressions or to simplify algebraic expressions. So the difference there, things with just numbers or things also with a variable. And they can be used for both, it doesn't matter. I do want to mention that the book we use assumes that if a base has, any base that has an exponent that's either 0 or negative, that base is going to be non-zero. So, 0 to some power. So our book assumes the base is non-zero, just so that you know. And all simplified algebraic expressions containing only non-negative exponents. Or sorry, I should say all. A simplified algebraic expression contains only non-negative exponents. So if your directions are to simplify, which that's going to be the bulk of what we do, it is only simplified when there are no more negative exponents. So you need to get rid of all the negative exponents for an expression to be called simplified. So let's look at some examples. Simplifying some numerical expressions here. Let's use our exponent rules first. So first of all, 3 to the 4th squared. So that's a power to a power, and when you have that, you're going to multiply. So 4 times 2 is 8, so this is going to be 3 to the 8th. And then we're going to evaluate 3 to the 8th, and it is 65, 61. Okay. Make sure that you can put these in your calculator to figure out what they are. The next one, and this is where these are nice to simplify fractions, so don't just put that in your calculator as is, because your calculator will probably give you back a decimal. So since it's a quotient to a power, that power goes to everything in the quotient. So we have 5 cubed over 8 cubed. Then actually I'm just going to do top and bottom and not worry about my calculator giving me back a decimal. So 5 cubed is 125, and 8 cubed is 512. And there's your answer. You just leave it just like that. And our last one here, we are multiplying with the same bases, so we keep our base, and we need to keep it in parentheses, and I'll explain why here in a second. We add our exponents, so negative 3 plus 9 is 6, and then we need to take negative 2 6 times, so negative 2 6 times is going to be a positive 64. So if you dropped your parentheses and you wrote it like that, that actually gives you a negative 64. Because the most important thing you can know about exponents is an exponent only goes to what it's touching. So in this case, it's just 2 to the 6th power, which is 64, and then you tack on that negative in front. And really, it's because of your order of operations. You do exponents before you multiply, and this negative in the front is really kind of multiplying by negative 1. But up here, you are taking negative 2 times itself 6 times, and a negative times itself 6 times will end up as a positive. So parentheses are very, 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 very important, and it all goes back to your order of operations. All right, I'm going to leave these 3 for you to do before class. You need to come in with them with the problems written out and the answers written out, please. And if you have any questions, let me know. Thank you, and have a great day. Bye.